Hello all. Today we are solving LeetCode problem number 1594, maximum non-negative product in a matrix. So you are given a m cross n matrix which is called as grid. Initially you are located at the top left corner, which is 0 0 position, and each step you can only move right or move down in the matrix. So among all possible paths starting from top left corner, which is 0 0 position, and ending in the bottom right corner, which is m minus 1 and n minus 1. So find the path with maximum non-negative product. The product of path is product of all integers in the grid cells visited along the path. So this is straightforward, right? So now we have to return maximum non-negative product, which should be modulo with 10 power 9 plus 7. If maximum product is negative, we have to return negative 1. So in this case, the problem, it is clearly given that the grid consists of both positive and negative values, and you have to find the product of path, and you have to return maximum product. If it is negative, in case of negative, you have to return negative 1 as the answer, because you do not have any positive answer as the output. And whenever you are returning any answer, you have to modulo that with 10 power 9 plus 7. So that is how you have to return the answer for this particular problem. So one thing to note is you have combination of both positive and negative. So in this case, the tricky part is if we need to calculate the accumulated sum for path, we can move the left, and no, it's not left, this is right, and down we can track the accumulated product. But for negative, we know that two negatives, negative multiplied by negative is a positive. This can be a big positive, so we cannot ignore this. So it is very clear that I think we have solved this similar kind of problem before in the in the same LeetCode daily challenge. So it is very clear that we have to use two matrix to track the negative. So which means you have to have two matrix, which is minimum accumulated product and maximum accumulated product. So each cell we fill this for minimum accumulated product, each cell will be filled with minimum possible value, and this will be filled with maximum possible value. So we will finally return, we will fill this minimum and maximum matrix, and finally we will return maximum of the last, which is negative 1, the last element basically negative 1. So we will return this as the output. So this is all about the problem. So now let us solve the real example and then understand how and what exactly we can do to solve the problem. So first example, it is completely negative value, and any possible there is no possibility actually to get a positive value from this position to this, to reach from this position to this position. So hence we are returning negative 1 as the answer. So we will consider example 2 for this problem. The output for this is 8. So it is clearly that we start from this position, we move down, and which is the accumulated product is 1, and we move right, the accumulated product is negative 2, and then we move down, accumulated product becomes 8, and then here it stays 8, and 8 is the output which we are returning because it is the maximum possible value which we can get out of it. So how do we solve? We will have a minimum matrix, so which is of same size as well, 3 rows and 3 columns, so which is m rows and m column and n rows, and we will also have maximum matrix as well. So standing at this position, it to fill this initial position, this will be the same because you do not have any accumulated value before, which is being carried from the previous element, because that is the starting point. So we will fill that with 1 and 1. And now we for filling this particular position, which is right and down, we will use this as the accumulated value. For according to this particular position, how do we fill in the accumulated value? We will be looking into the previous value, which is 1. Which is 1. So 1 multiplied by -2 is -2, right? So this position we have -2, and there is this one and only position, one and only value available, and this will be the maximum value and this will be the minimum value as well. So we fill this as -2 and -2 here. So one thing to observe in this row 0 is it is multiplied, the accumulated value will be multiplied with the grid only, because you have only one possible outcome, so there is no need to check for the minimum or maximum. So it will be simple, because in zero throw you have only the left value available, there is no top, so only we can move right side. So this will be very simple. For I is equal to 0, you can have to fill this 0th row, and similarly it applies for j is equal to 0 as well. For 0th column also you have to multiply that with grid of I. So this will be -2, because 2 is the previous one, so multiplied with 1, this will be -2, and there is no maximum value, so maximum value will be also -2. And similarly 1 multiplied with 1, this will be 1, and maximum also remains 1. And then 1 multiplied with 3 will be 3, so this becomes 3 and this becomes 3. So now challenge comes only to fill in these middle values for this and this. So now at this position you have the top and the left, right? And also you have the minimum value and the maximum value. So you have totally 4 cases will be generated. So from that you will take 1 minimum and 1 maximum. So now looking at this, you have -2 from minimum and -2 from maximum, and 1 from minimum and 1 from maximum. So 1 and 1, and this will be multiplied with the actually this is the the accumulated value, and this will be multiplied with the current value in the grid, which is nothing but -2. So -2 and -2 and -2 and -2. So these are all the accumulated value, and this is the actual value. So you got 4, 4, -2 and -2. So minimum is -2 and maximum is 4. So you fill 4 here and fill -2 here. So now we have to fill this particular column. So similarly we have 2 here for left and 4 here from max, 2 -2 from minimum and 4 from max. So -2 and 4. Then from top you have -2 and -2. So -2 and -2. So now consider this 1, this value, the grid of ij is 1, so you multiply with 1. So you get -2, -4, I'm sorry, -2 and -2. So the minimum is -2, minimum is -2 and maximum is 4. So this will be 4 again, and this will be -2 again. So now at this position you have 3 in the left, and 3 for maximum. So minimum is 3 and maximum is 3 as well. So 3 and 3, and top of this you have 4 and -2. So 4 and -2. I think this should be reversed because we will process by minimum and maximum. So now we have to process with this grid of ij, which is -4. So you have -4, which is -12 and -4. So this is 8 and this is -16. So minimum is -16 and maximum is 8. So you fill in this with 8 and this will be -16. So now you have 16, 8, -2 and 4. So -2 and 4 and 8 and -16. I think this should be reversed. 8. So now this would be multiplied with 1 because grid of ij is 1. So 1 and 1, you have -2, 4, -16 and 8. So now this will be filled with 8 and this will be filled with -16. So now that we are done with filling this matrix, so now we have to return the last element, which is 8. So this is what exactly we are going to return as the result. So result is equal to 8. So this is how we are going to solve. The time complexity for this is big O of mn because we have to process through the grid. N, this is row into column. So with this idea, let us go and code this up.
So we start with n is equal to length of grid and m is equal to length of grid of 0, and now we will have the mod value, which is 10 power 9 plus 7. So now the initial value is done. We have to create two matrices, which is the minimum and the maximum. So min mat is equal to initialized with 0 times m for I in range n, and this maximum also is same. So that is what exactly we are initializing. So I'll just change the name, maximum matrix. So yes, now we have to iterate through this matrix actually. So for I in range times n, for j in range times m till m times, m has a range, we have to fill in the first value actually. So the 0th position, 0 0 position will be replaced by the grid of first value, that means the grid of 0 0 value. So in that case, min mat of 0 0 is equal to grid of 0 0. So this same applies for maximum as well. So now that this is done, we have to skip the 0 0 part. So in that case, if I is equal to 0 and j is also equal to 0, in that case you have to skip this. So continue, and now you have to fill in the 0th row and 0th column. So if I is equal to 0, this is for 0th row. So min mat of I and j is equal to min mat of this should be filled by the top value, right? So So in that case you have to be, it should be same row, and it should be same, I mean the top column. So in that case this is how we fill in, and this should be multiplied with grid, because that is one only available direction which with which we can use it. This is top column means this is the previous column, in fact the left one, right? So yeah, so this should be multiplied with grid of I and j. In terms of maximum also we have to do the same, and this should be maximum. So for 0th column you have to handle the rows actually, so because you will be filling based on the top value, which means the previous row values. So if j is equal to 0, so this I think we can copy it and we can reuse, but we have to modify this one because j remains the same. It is only the I minus 1, the previous row, and the previous row as well. So that is what exactly happens in this situation. So this should be else if elif, I'm sorry, confusing with so much of language. So now the else part comes in, where you have to check for the 4 cases which you will form by the help of minimum and the top one and the left one, and maximum and the top one and the left one. So you have 4 product values. So product 1, product 2, product 3, product 4. So you have 4 values here, so which you can calculate by minimum mat of I minus 1j multiplied by grid of ij. So this is for this, and now the next one will be for maximum. So max matrix, the same thing, which is I minus 1 multiplied by j and multiplied, I mean I minus 1j and grid of I j, right? So next one will be the same, but this will differ by the column. So I think better we can copy this to avoid any typo mistakes. So this will be the previous column. So and here this will be maximum and the previous column. So now that this is done, you have to fill in the minimum matrix and maximum matrix based on finding the minimum among all the 4 values. So in that case, min mat of I and j should be filled with minimum of product 1, all the 4 products. So this is 4 and 3, this is 2. So we will copy the same and place it here as well. Here you have to replace with replace for maximum matrix, and this should be maximum. So that is how you fill in these minimum and maximum matrix. And now finally you have to return coming out of the loop, you have to return the maximum matrix last value, which will have the result actually. So in this case you have to handle this part as well, because you have, if there is maximum product is negative, you have to return -1, right? So in that case, yeah, in that case, if result is equal to max mat of -1 and -1, to get the last value. If result is greater than or equal to 0, then return result, else return -1. So this is it. Let us run it and submit it. Oops. Yeah, I just forgot to return this value mod. Return the value by performing the mod. So this is it. So now we have to run it and submit it. Yeah, now it works fine. That's it. Thank you.